Hello everyone, my name is Abhishek Pandey and welcome to this demonstration of my project on automation, database and backup and restoration on AWS. In this mentorship, I have integrated various AWS services and tools to create an efficient and reliable solution for managing databases in the cloud. Let's dive into the process from setting up AWS resources like RDS, Amazon RDS, relational database, and S3 Bucket, and many more services to running and automating the script. So this is the Amazon management console. Here we have signed in. So our first task is to setting up AWS resources. Like firstly, let's look at the AWS resources. So I have set up an Amazon RDS instance. So we have search here RDS. So this is an Amazon RDS dashboard. So we have databases here. So I have set up an Amazon RDS instance for our MySQL database. So this is our RDS instance, Amazon RDS instance for MySQL database. So we have created to ensuring a managed and scalable solution alongside that. We have also, yeah, this is our Amazon RDS MySQL database. So here we have something like we have connectivity and security in this section. We have endpoint and ports. So this is endpoint where we have to use this. We use this for we use this for we use this for connecting to our database server. So we have endpoint and we have port 3306 and we have things like here I have created my RDS instance like DB engine version 8.0.33 and my DB instance identifier name is randomDB and I have also give the password here and the instance configuration are brush table classes include T classes like I have db.t2.micro one CPU and 1 GB of RAM and I have also general purpose SSD. So we have this type of I have connectivity IPv4 and I have default security group here and default VPC here. So these are my RDS instance configuration. So configure our VPC and subnet like we configure our VPC to public accessible and also we have security groups. So we have configure our security group like we allow inbound traffic on multiple ports like 3306 we have from our trusted IP address. So we have seen here like it opens. So here we have security group of our RDS. So we have all inbound traffic on MySQL. So we go to inbound rules and we have to see what our security groups configuration. So we have configuration all traffic allow and we have my IP for connection and these things here we have configured the inbound rule for our to access our MySQL RDS. So this is updated successfully. So we have now our RDS database is ready and our next step is to populate the RDS instance with sample data. So we have opened our MySQL workbench. Our next task is to populate the RDS instance with sample data. So we connect to the RDS instance. We have MySQL workbench here to connect with the uh, uh, to populate the RDS instance with sample data. So you see here. So I have to make a connection with my database to connect to databases. So we have here. So here we have to give host name. So like we have to give here endpoint. Do you see? So from from here we have copy this endpoint. So we copy this endpoint and we have login. So here so here we have localhost. Here we put paste our endpoint and here we give our username admin. So this is the so we also give our password. So here we give our password. So by this we have logged to our so by this we have logged into our AWS RDS. We are connecting to this. Our RDS instance is connected to MySQL workbench, like MySQL at the rate randomdb.c90. This is our console of MySQL workbench connected with our AWS RDS. So here our next task is to create a schema and insert things in there. So here I have create database MyDB and use MyDB. So here I create student database like so as you say there, I have successfully created a database by using create database Abhi02 and also created a user create table users and I'll give the all the things like ID, name, email, and password, virtual contact, and also I have used insert insert command like insert into user. So I'll give the format ID, name, email, password, contact, DOB, and I also give the uh, one at ID and John, name John, and email it is password and contact and DOB. So so I'm successfully do this. So our task 2 is completed and we jump into task 3. So our task 3 is now this is our task 3. So I have also established an S3 bucket to store our automated backup securely. So this is my S3 bucket which I established. So so generally Amazon S3 is a simple storage service is a scalable object storage service provided by the AWS with S3. So we can store and retrieve any amount of data at any time. It's designed to deliver 99.99% of durability. So that's why we use this. So while creating S3 bucket, we have see that here I'll give my S3 name, my Abhi bucket 01. So here in AWS we have to provide a unique name for your our bucket like the bucket name are globally unique across AWS. So we might need to choose a name that distinct. So we also have to choose reason. So you see that I have configured my S3 bucket according to our project, like block public access. So I have block public access in there for our project. Like starting, it recommend to block all public access to ensure the private. So these are the bucket block public access configuration here according to our project. So in the task 3, we have also create an IAM user identity and access management. So we have to create an IAM user and grant them permission to access the bucket if needed. So we have to create an IAM user. So alongside with this, I have also created the IAM user on the 01, which have the permissions like that we have seen our in a screen. So for this IAM user, I have give permission to several services like administrative access, whole access, and Amazon RDS full access, Amazon S3 full access, and AWS Lambda full access. And these are the permissions which I give this IAM user to secure like IAM roles and users have been configured for secure access. For secure access, I will give this permission. So in our project in the task 3, we have also configured lifecycle policies of S3 bucket. So here we have management tag. So we go to the management tag and we have also defined lifecycle rule. So so for this we have transition object transition or we have set after 30 days it automatically deleted from here. So we have here the no life cycle rule is there. So we click on the create life cycle rule. So for according to our project, we have to 30 days. So give the life cycle rule name. So S3 underscore 30. So after 30 days, it will automatically delete it here. So for this, we have to create a life cycle rule. So here, what we have, so we have expire current version of object. So we click here for after 30 days, it will delete automatically. So days after object creation. So days after 30 days after object creation, it will automatically delete it. So our task is complete. Task 3. So create rule. So we have create rule for the configuration of life cycle policies of S3 bucket. So our life cycle rule for S3 bucket is completed. So our task 3 is completed. We start task 4. So in the task tree, we have also manually uploading a file in the S3 bucket to ensure that to confirm that our permissions are set correctly and that the bucket is ready to integration with our RDS backup script. So we also manually do this by the MySQL dump. So we do this. Now we have take backup from command prompt by using this command. MySQL dump --set -gt purgd is equal to off. -h means random DB, like -h means host endpoint, like we have here endpoint. So we use this endpoint to connect to here, and we have p is port number, -u is random DB, like our database name, and user, and -p is password. And this is a file where we uh, we save our backup. So we run in the Windows command prompt to take backup from here. So we go to the Windows command prompt and run this command. So it successfully run the command. So see the back. We see the this is our backup file. We have see. So this is our backup file which we have backup here. So our command is successfully run and our backup is also done. So this means our RDS instances, the permissions and the things are perfectly. So So we have backup here. You see here. So we have successfully completed our task 3. So we move on the task 4. So so till now we have done all the things manually, like we have uh, create RDS instance and the create S3 bucket, and we take backup manually. So our next task is task 4 is to write an automation script where for our project the main goal is to have Python script that we have connect to our RDS AWS RDS database instance and initiate a backup or restore process. And the third part is save backup to or retrieve them from our S3 bucket. So we have go to our VS Code IDE. So I have written already a Python code. So let's dive into this. What about what code, what function do? So so now let's delve into the code base in our scripts. We are utilizing AWS Lambda function for automation. IAM roles plays a significant role here, and sharing our Lambda function have the necessary permissions. I have also configured my MySQL Workbench for compatibility. Let's me walk you through the key script and their purposes, showcasing how each piece contribute to all over the automation process. So these import sub process, import OS, import time, import PyMySQL. So these modules allow you to spawn import like import sub process. This module allow you to spawn new processes, connect to their input output error pipes, and obtain their return codes. In this script, it's used to execute shell commands. So this is used for the to execute shell command, and the import OS is the OS module provides a way to interact with the operating system, such as reading or writing files, manipulating path. And the import time, this module provides various time-related function in this script. It's used to generate timestamp for creating unique backup file name. So the import PyMySQL here, this module provides a Python interface for MySQL database operations. So these are the things. So we have here timestamp in this line. So this defines like timestamp is equal to time string or f time. So this is the format of our time function. This is our database name which we make in the RDS database, and the backup database name which we want to take backup. So we give the college backup, and the table name is the student what we make. And the download file name is download underscore backup dot SQL. So these are the things here. So so this coming down, so we have so the backup def this is a function backup event comma context which we have. This is a main function that will be executed when the lambda function is triggered. So db host, db user, and the db password, and db are database connection details such as host, user, and password. And this is an S3 bucket name. It specifies the AWS S3 bucket where backups will be stored. And this Python code like this this Python code db is equal to PySQL PyMySQL dot connect, and these are the details which we give to connect our code. So this piece of code establishes a connection to the MySQL database using the provided connection detail. And the rest of the code like this. So SQL is equal to create database if not exist. So this create the main database if it doesn't already exist. This line of code. and we get, and this line of code in this cursor dot execute and data is equal to cursor dot fetch all. These are the codes. We select the main database and creates a table if it doesn't already exist. So we have insert sample data. We have insert sample data into the table, retrieve and print the data here. And we have also create MySQL, create a backup of MySQL database and copies it to specified S3 bucket. So this is our table. Like we have F name and L name, last name and first name is Hare Krishna, and cursor dot execute dot SQL. So we have these things in our code, and that this function like dot close here this line we have to ensure that a temporary file for the downloaded backup exists. So this download file is ensuring that download the backup file from S3 to the local /tmp directory. So we have also this thing like Boto3 import Boto3 like create a AWS client to connect to the S3 bucket. So we have this in our code, like we have so this backup finished, and we have check the return code from the restoration process and print a success or failure message. So manually invokes the backup function for testing purpose. So the code doing these things in our code. So we have in our step 4, we have all the things like connect to our AWS RDS database instance, and the second part is initiate a backup or restore process, save backups to or retrieve them from our S3 bucket. So this code consists all the things which the our project need. So we let's run the code and see what happens, like if code runs or not, and the backup is uh, going to S3 bucket and by local storage C colon hyphen hyphen mr. So let's run the code. So we run the code here. So we see here database database backup is com MySQL backup is finished. So our code is run perfectly. So let's check that, yeah, it's run perfectly, like Abhishek Pandey and Hare Krishna. These all things are MySQL backup is completed successfully. So let's see in the our S3 bucket that it is come or not. So we see here in our S3 bucket, we see there here is our file. The date is 13/11, and this file is November 13, 2023 is this current file we have uploaded successfully backup. And we also see in our local storage which what we give in the path. So this backup, so we see in this PC local disk, and we have MR. We have give the path of, yeah. Here you see the download backup is underscore backup is coming here. So our code is successfully run and restoring, and the backup process in S3 bucket is also done. So, our task 4 is also completed. We open this file to see that our backup is stored on here. So you see we have this backup. So we have successfully created a backup of our and restore it of our with our code Python script automation. So this is my download underscore backup file. So we have successfully do this run our code by automatic script. So we close this and so by this we our task 4 is completed and we go to the task 5. So our next task is to scheduling task 5 is scheduling and automation. So we use AWS Lambda is a serverless compute service that lets you run a code without provisioning or managing server. And we also use Amazon CloudWatch. And we also use containerization with Docker. So we use Docker for containerization. So next up is Docker containerization. I choose Docker to ensure consistency across different environments. Our containers are built and stored in Amazon ECR, making deployment and scaling more manageable. This is step enhancing the portability and efficiency of our solution. So we use AWS Lambda and automation here in our task 5. So so we so I what I do for the task 5, I have uh, I have downloaded the Docker desktop you see here. So we open this Docker desktop.
So we are in task 5. So in task 5 we have to do scheduling and automation. So for this purpose we need Docker and the Ubuntu terminal. So I have installed the Docker. I have set up the Docker with WSL to like Windows subsystem for Linux. So we have integrated. So WSL is a feature of Windows that allow developers to run a Linux environment without the need for a separate virtual machine. So I have installed the WSL integration Docker with Ubuntu terminal. So we have this for performing the next task. So I have also uh, I have also create a new directory in there. Like my directory name is my AWS backup app. So I have also installed I have also configured my Lambda function and all dependency like Boto3 and MySQL connector Python. So I also install the required package using pip command. So what I see here, so these are the dependencies or what packages I have to run my things. So I have set up my environment in this and also zip my Lambda package. So now what we have to do here, like we have to see that Docker is running or not. So we have check so Docker and we see here the Docker command is running here. So let we see the Docker is running or not. So it takes time. So now you see that the Docker is integrated with my Ubuntu terminal. So the Docker is running perfectly. So now we go to the our AWS management console and create our. Uh, we have used Amazon Elastic Container Registry. By this we have create repo here. So normally we have create repo here. So give the name of the repo. So I'll give the test repo name and then we create repository. So in tab to the create repository tab, so it's ready, it's created. So now now the test repository is created. Now simply we have what we do, like open the test directory, and we have some view push command. So these commands we run in our Ubuntu terminal for the process of login process, and for the Docker build process, and for the Docker tag test, and also for the Docker push process. So we run all these commands in our Docker file. So we run that. So simply copy from here, and we run these commands in our Docker terminal. So paste here, and we also give sudo, because so here we give sudo that for running process. So we press enter, and then it asks for password. So I am a root, so provide root password. So I'll give the password, and then it's sign up successfully. It's so after taking password. So here you see I login successfully. Here login succeeded. So we copy our next code here, docker build hyphen test underscore repo. So we have also running this. So by this we have so also here we also use sudo command. So we write here sudo su there. So so after running it building the docker image. So it's running now. So now you see the building process is completed. Like you see here, like naming to Docker this, and these step is completed. Now we have copied the third command. So Docker test repo. So we also give name either copy here, and normally we also here give the sudo command, sudo for the super duper user. So here we give sudo, and then run this. So here run successfully. So we copy the next command from here, and we do the thing same. So we open this and paste this. Then what we do, again we give sudo, then again we run this command. Here you see all the things are pushed to our ECR. So these two pushings are remaining. So you see all the things are pushed. Now we have the latest digest here, latest digest. So we check, like here in our ECR. So this is 6A6. So we close this, and we check here in our ECR file. So we check here any image comes or not. So we say here one image is created. So latest digest is this. So image. So we have this latest digest, like in the, and it is 6A6. So this is our latest image, 14 November 2023. So this is our, so what is the next task is to create a function, create a Lambda function. So what we have to do, go to the Lambda and open the Lambda. So here what we do, create function in our Lambda function. So in this console we have choose container image and we give the function name, like we have choose function name my underscore function, as you will see function, and in the in this container image we browse the image what we digest, latest digest, so test repo, and what we have in the latest digest we select this. So latest digest, select, and then select image, and then we have the main thing here is we have permissions. So here I have created an IAM role with several permissions like CloudWatch and S3 Bucket and RDS. So I use an existing role. So I click in the use an existing role and create, and I have created already a IAM role. So click here and all the things are set. So now what we have to do is create function. So the create function creation is going on. So here in the configuration we also do some changes, like in the memory I have to give 256 MB, and at the time I have to give 1 MB. So this is the thing, and we have to save the changes. So changes are successfully updated. So what we have to do, we have to normally test our code. So click on the test tab. Now what we have to do, test. So our execution function is started 21 seconds. So this the function is totally run, and the output is, so you see here the function is totally run. So function, this my code is successfully run, and it takes 5401.20 milliseconds. And we also see logs in the CloudWatch. So we also see that what the things is that there. So CloudWatch management console here. So what we do in the CloudWatch management console, like we have to watch relevant and any relevant logs. So we have this. So this is our CloudWatch page. You see here. So here I also want to explain my Docker file which I use here. So normally I'll go to our Docker file. So what we see, like we open with cat command, cat. So our file name is Docker file. So I'll explain the Docker file what we do in the Docker file here. So we open our Docker file. It's opening now. So our Docker file is open. So here we explain what the code is are. So the arg function underscore directory is equal to this home app. This will define a build agreement for the function directory, and the home app is, yeah, like that. And the line, this line define a build argument named function dir and sets it default value in the home app. So build argument is used to parameterize Docker file instructions. So we also use here the official Python image with the slim buster tag, here, as this line is specify the base image for the Docker image, it should the official Python Slim Buster image. So here the Slim Buster tag indicate a minimalistic image based on the Debian Buster. So Docker file. So we have defined the function directory argument here, and we also command. So what we have next, like we have run function. So this line creates the directory specified by function directory argument using mkdir p command. The p option ensures that the parent directory are created if don't exist docker file in docker file. So the all python. So this copy asterisk dot py function, what this function shows that this function shows that this line copies all the file in the directory, build context to the directory specified function directory. This is a common approach to including application code in the Docker image. So what the next things update, what the next thing we do, like update package list and install necessary dependencies, like run apt get update. So these are the dependencies which we have to update. So this section uses the apt get package manager to update the packages list and install necessary dependencies. It install development tools like G++, make, CMake, and unzip libcurl, which might be required for building certain Python packages or system level operations in the Docker file. So we have all the things here. So run Python 3M pip install. These are the AWS Lambda runtime interface clients. So these lines install Python AWS Lambda, AWS Lambda, rig, MySQL, Moto3 using pip. These packages are essential for the AWS Lambda function that interact with AWS services and Docker file. So these are the things which we use here. And this and we have also working directory, function directory, and entry point. We give the this path usr local bin python 3. So in the cmd we give main.py. So what this line specifies the default command to the executed when the container start. In this case it runs the main.backup function. The cmd instructions provide a default for an executing container but can be overridden in time. So we have these all the things we have. So thank you for this. So we I also suggest like what not to do about avoid here. So uh, I have difficulties. I am facing difficulties in my security group. Thanks for Sai Kumar sir for the resolving this secure problem. So remember that give the right permission to our security group to access our Lambda function. So thank you.